so the idea is really to get yourself familiar with practicing these, and once you get the idea, it should be really easy. So let's do a couple of examples, and we'll see how we can apply this concept. All right, so this is from chapter 2 of your book, and we'll pick a couple of end of chapter problems and see if we can apply this. So before you even start, as long as you identify this is a SUVAT problem, a kinematics, one-dimensional kinematics problem, I would write down on the corner all the equations first. So that's V equals U plus AT, S equals to U plus V over 2 times T. Remember, this is basically the average, right? The average average velocity. And then we have the one with the half AT square. This is how I call it. It's the UT plus half AT square equation. So that's basically the velocity and acceleration equation. That's the half AT square. And the last one is the U square plus 2AS one. They don't have fancy names. That's all I call them. All right. So now we can adapt the 3-step process. Number 1, draw a diagram. Number 2, state all your givens and the aim. Number 3, find the right equation and solve it. All right. So let's draw a diagram, right? The way I do that is look at it line by line. So a helicopter is ascending vertically with a speed of that much. So vertically meaning I need to go up and down. All right. So that's my helicopter. It's the best I can do. It's going upwards, vertically ascending, right, with the speed of that. So it's going upwards at a speed of 5.1. Okay, so now I see that everything is in SI units, meters per second, etc. So I can actually just suppress the unit. Also, is this the final velocity or the initial velocity? I'm not quite sure yet. So be careful. I might need to change that, right? So this is the general strategy of doing these problems. Things might change along the way. Okay, and then at a height of 105 meters above the Earth, a package is dropped from the window. How much time does it take for the package to reach the ground? Okay, so this is moving upwards, and at a height of, let's just label all the information first, 105, and the packet is dropped, and we want to find the time. So this is going to be my diagram. It's always helpful to start with the diagram. Okay, remember the 2 things to include is number 1, the origin, and number 2, the axis. All right, so I'm going to define positive y going upwards like this. And are we interested in the package, or are we interested in the helicopter? So we're interested in the package, right? So we need to be, what we want is time for the package to traverse this height, the time for the package to traverse this distance, the initial speed of the initial velocity of the package, and the final velocity of the package. Everything should be package, okay? So there's a hint, says that the V0, which is the initial, right? V0, so V initial of the package equals to the speed of the helicopter, right? It's ascending at this speed. So that is now the initial velocity of the package, right? So the package is going to drop from here to here. All right, that's the path. Oops, if I can adjust this, maybe not. It's going from here to here. There we go. Yeah, so the U is the package, and when you're just dropped, because you're in the helicopter, so you kind of share the same speed as the helicopter as you drop it, because the package is moving up already, even though you put your hand outside the window and you just drop it, but the moment you release, it's already going up at that height. Should this be positive or negative? Should be positive, because I'm defining y this way. All right, what else do we know? Well, we know that it's going to accelerate downwards with g, but I need to put minus sign, so the acceleration will be negative of g. G is 9.8 or 9.81. We'll use, they're giving things in 3 significant figures, so we'll use 3 significant figures. Okay, so yeah, and yeah, so that's the distance. All right, so I've got my origin here. That's my y equals 0. In essence, this is going to be minus 105 if the distance between here is 105, like that. Okay. All right. So let's write out our givens. SUVAT. So S is the displacement. So it's going to displace 105, but is it negative or positive? Well, if this is positive, then my displacement is negative. U is going to be positive. I don't know the final velocity. The acceleration is negative 9.81, and I don't know the time. In fact, that is my aim. So I've stated all my givens and all my my aim that I need to find. Okay, so the third step. So that's the first step, draw, and the third step is to select the right equation. So I really care for t, so I better have one with t. So that eliminates this one. I will pick one of these. And I don't know v, so I'll pick one without a v, right? So this is going to be the one. After some practice, you'll immediately know which one to pick already. All right, so we can give it a go, right? So s equals to ut plus half at squared. I know I'm reproducing it, but when you write solutions, always start off with reproducing what equation you're using, telling the reader what equation you're using before you start. And then now we can go ahead and plug and chug, right? So S is minus 105, U is plus 5.1, T plus half A is minus 9.81, T squared, like that, right? So what am I trying to solve? I'm trying to solve for T. Well, I have two T's over here. How do I isolate it? Well, this means it's a quadratic equation, right? So I have a quadratic in T. So we probably need to use the quadratic formula for this if we cannot factorize it, and these are not nice numbers. So let's put everything to the left-hand side. So this is minus, what's 9.81 divided by 2? Let's get some of the equations out of the way. In fact, yeah, let's move it without calculating the value first. So it's clear for the reader what we have. So 9.81 t squared. I'll move this to the other side as well. So minus 5.1 t minus 105 equals 0. So it's clear I have a quadratic over here, right? It's, yeah, now we can use the quadratic formula. I'm just deciding if I should write one more step to simplify that. You know what, for the sake of clarity, let's do that. So we can do 9.81 divided by 2. So that's 4.905. So 4.905 t squared minus 5.1 t minus 105. Okay, if you forget your quadratic equation, you can look that up. T is minus b plus or minus square root of b squared. So I have 5.1 squared. I know it's minus 5.1, but square doesn't make a difference. 4 times a, 4.905 c, so that's 105 over 2 times a, 4.905. Okay, all right. So yeah, just in case you forget, if you have a quadratic equation like this, it's minus b plus or minus b squared minus 4ac over 2a. If you forget, you'll see that in your equation, that is equation sheet that's given anyway. All right, so this is the b is negative, so it's a, b, c, right? So c is minus 105, b is minus 5.1, and then a, just be careful of any double negatives. Those are potential area of mistakes. All right, so now let's just plug all this in the calculator. All right, so I have minus, so here I have minus, so I'll just do 5.1. We'll do plus and minus separately. Okay, so we'll do plus first, square root of 5.1 squared minus 4 times 4.905 times minus 105, all right? And the whole thing is going to be divided by 2 times this, but that's just half of 9.81, so 2 times that, it's just going to be 9.81. Just going to make my calculator a little bit shorter. All right, so I get 5.1. So one answer is 5.17. Let's put one more decimal place in case we need to round it, because we're going to round it to 3 sig figs. So let's have 4 so we know what to round in a second. I'm just doing the math first and not the physics. And also, let's repeat that, but this time with a minus over here. Okay, and I get minus 4.136. Let's go with that. All right. Remember, now that we have the math done, we need to select three things, right? So we want to check if we need to reject negatives. Sometimes we do, sometimes we don't. We need to check our significant figures, and we need to check our units. Okay, so I'm calculating the time of the package, right? Does it make sense for time to be negative? Not really, right? So we just select the 5. So the answer here, if I have, if I make a little bit more space, it will be good if everything is in going vertically instead of horizontal. So I will do that if I just shiftify this a little bit up there. All right, so I can put this here. That would usually be better. And the answer over here, so we can say, therefore, the time it takes is 5.17. So we will round that up to 7176. We'll round that up to that and reject a negative. So it takes that long to land. Okay, all right. So give it a try yourself and see if you can reproduce this answer.